Hello and welcome to another video. In this one, we're going to be talking about merge queues. GitHub recently launched their merge queue feature in beta, and I want to talk through what it means, why you might want to use it, the trade-offs of using a merge queue, etc., etc. GitLab also has a feature that's very similar to GitHub's merge queues called merge trains. Sort of funny story. I almost got banned from GitLab for pointing out that a run train button is maybe not a good choice from a product perspective. But anyway, that's off topic. We're talking about merge queues today. So let me first describe kind of the default setup for how pull requests get merged in a Git repository. We're going to be talking about sort of a linear merge-based workflow. This also applies to a rebase workflow or a squash workflow, but for simplicity, we're just going to be talking about merges today. They all work the same, but it makes my diagrams easier to draw. Okay, so typically you have a linear-ish history on your primary branch where these are represented by a bunch of pull requests. When people make their own feature branches, they branch from a particular point in time. So you can imagine one person created a fork of the main line and made their commits here. You can imagine some time passed, other things got merged and someone else made a pull request here, etc., etc. We'll represent this as 3 merge requests today. And these pull requests might be all green. So you can imagine this is a green pull request, this is a green pull request, and this is a green pull request. And in the default mode of how GitHub is configured, these can all be merged at any time, independent of how they were branched. So you can imagine, maybe this one gets merged first, and then this one gets merged second, and this one gets merged third. Cool, everything's great. It all works for the most part. The problem with this setup, and one of the problems that's solved in a couple of ways, including merge queues, is despite all of these branches being green, and despite none of them having any actual merge conflicts, and they could all successfully merge, they could all have green checks on their pull request, it is possible, and if you're in a big company with lots of contributors or people are working on the same thing, it's very likely that these may cause a failure on the main branch. And the reason for that is what I like to call an implicit conflict, or a merge race is another term that I've seen thrown around. The idea is that despite the code not actually being a merge conflict, it causes a failure in tests due to 2 or more changes that implicitly conflict with each other. One of the most common situations that happens in a indirect conflict or in a implicit conflict is one branch adds a new reference to something and the other branch deletes all references and the import to it. That is probably the most common one that I've seen over and over and over. But in this scenario, that is possible. It's possible to break the main branch even though everything started green. One solution to preventing the main branch from going red due to these implicit conflicts is a setting that's already already possible on GitHub, and it is one way to solve this problem, which is to use a require branches up to date branch protection setting. This is one way to solve this problem, and again, the default setup here. It's always trade-offs. In the default setup, you're trading off speed for correctness. This is the fastest way to integrate changes, but you have some correctness issues. Like sometimes it'll break the main branch. I actually recommend this for almost all scenarios, except in scenarios where you have lots of developers, lots of people working on the same thing, or extremely large monorepos or monoliths. Think like big company problems. You're probably not going to bother with a merge queue or with this require branches up to date setting on a small microservice or a small open source project, even like a medium-sized open source project. This probably, trying to mitigate this is probably a waste of your time, including merge queues. Okay, but what require branches up to date means is, let's say we take this original scenario here. Oh, dang it. We're gonna copy paste this. That way I can show what's going on here. We'll redraw those 3 green lines here. So this merged and then this, that's curvy line. Diagramming is hard. Okay, 1, 2. That's gonna be off the screen. I'm sorry, I'm wasting so much time with this silly diagram. Okay, so in the require branches up to date setting, what happens here is as soon as one of these branches merges, so let's say that this oldest one merged first. Actually, it's impossible for this oldest one to merge because it would have to be up to date first. But let's assume that this oldest one rebased, got a green branch, and then merged. So this is after rebasing on the latest tip. This would force all these other pull requests to have to rebase their branches, and then they would be mergeable afterwards. And so this setting can be really bad in a contentious repository because it means that every time someone merges, everyone else has to rebase, which is a trade-off in the complete opposite direction. So in that case, you ensure correctness on your main branch because everything's up to date. A merge is really just a fast forward from something that's already been checked, and you get that correctness, but you sacrifice a ton of speed because every time something merges, everything else is invalidated. So I never recommend this setting. I don't think this setting is good, and it really hinders developer velocity. The other option to this is to use a merge queue, which is a newish feature on GitHub, a merge queue. And what a merge queue does is instead of having, I should have copied, maybe I can paste it again. Ah, sweet, I can paste it again. Okay, so in a merge queue scenario, so this, just so we don't lose track of what's what, this is our require up to date, and this over here is our merge queue. What happens in a merge queue is PRs that are ready to go are marked for merge, and then the merge queue system, whether it's GitLab or GitHub or some other third party which does this, because there are entire startups built around this, although they're about to lose all their business to GitHub's features. Anyway, what a merge queue does is it takes marked for ready pull requests, rebases them on top of the tip of the branch. So you can imagine we get a special branch here, which is the result of merging. Let's say these two were ready to go, this one wasn't. And then in that case, it wouldn't be a long branch like that. So what it does is it waits a little bit to merge branches, potentially collecting a bunch of branches together, and then it'll run checks on that collective branch. And if that collective branch is green, for instance, it will become the new mainline branch because you still have your linear history here. It looks a lot like as if the merges had already occurred, but it won't promote this to be your primary branch until all of the checks have passed. And so this basically ensures the same guarantees that this require branches up to date thing does, but it allows you to merge ever so slightly sooner. The other side effect of running the checks on this merge candidate branch is you don't have to rerun them on the primary branch because the primary branch just becomes this tip commit here. But again, everything is always trade-offs, and so it's not exactly the same speed as this because the merge queue system waits a little while to collect some branches before trying to perform a merge queue. This is so that it can actually batch things. If you didn't batch things at all, you're really in this scenario, except you have to wait the whole test suite length for the next things to start getting mergeable. And so this is a trade-off in the other direction. Now, in theory and best case scenario, the just merge things to mainline and a merge queue, they operate at the same speed. In the absolute best case. And the absolute best case is only one person is making a pull request, and the merge queue starts immediately when that person clicks the, I'm ready to merge something button. In the worst case, merge queues are quite a bit slower than this case over here, but they ensure correctness. So always a trade-off. Trade-off here is speed, correctness, speed, correctness. And the slower case here is that you have to wait for the queue time to batch things up, or you have to wait for an already in progress queue item to happen, or the already in progress queue item ahead of you fails, and so you have to start over. And that's kind of the worst case scenario. But you can imagine here, if we had an implicit conflict based on these 3 pull requests, in our merge queue scenario, if we merge them all into this candidate branch, the candidate branch would be red and you wouldn't be able to merge things. Now, merge queues aren't all sunshine and rainbows. There are a few scenarios where they don't really make a lot of sense. And again, I talked about those earlier for smaller repositories, microservices where there's not that many people, generally open source stuff. They're also not great if your test suite is fast because it doesn't super buy you anything. It doesn't really make it faster if your test suite's already speedy. The other scenario when merge queues don't work very well is if you have flaky tests, because this merge candidate branch is very frequently going to, false positive and be red and not be mergeable. So you'll not really be able to take advantage of mainline being green because, well, your merge candidates are going to be red all the time. But yeah, that's basically this. I'll show quickly how to set this up on GitHub. You have to be in an organization. You can't do this for personal repositories for some reason. I don't really understand. Wait, is that not where this lives? Oh, right. Thinking of identify. I was like, pretty sure I config v is for pre-commit. Oh, but it's one of my repos. The way you hook this up is you have to have a branch protection. So here, I don't have a branch protection, so I will add one for main. You will, you will check the require merge queue option, which is in beta right now. You can configure all of the settings here. I don't know why this setting is here. This feels like a setting that doesn't make any sense because the whole point of merge queues is to make sure they're green first, but I don't know, whatever. The other thing that you'll have to do is you'll add the status checks that you want. So where are those? Require status checks, and you'll hook up any of the ones that you want. For instance, if you want to pre-commit CI or your GitHub actions, what are my GitHub actions called? These ones. One oddity with how these are hooked up is you have to enable your GitHub actions for another event. By default, these aren't going to run on your merge candidate branch. So you have to make sure you go in here and what is it called? Merge group. You need to add another trigger to your GitHub actions. Pre-commit CI already understands this trigger because I did the work on Saturday to make that happen. And then once you're done with that, you'll just click create, and then you'll have your branch protection, and then any merges will go through that merge queue to get promoted. I did an example test of one, demo MQ, where I played with this a little bit, and you'll see, I don't even know where it shows up. It shows up somewhere, but it will make a merge queue branch, and then it'll merge it directly. So this branch right here was merged due to a merge queue. I think it shows that in the pull request. Yeah, merged via the queue into main with blah, blah, blah. And it'll also show the merge queue checks on that branch as well. Anyway, that's merge queues and this brand new feature from GitHub. It works pretty similarly in other things, and hopefully now you understand the speed and correctness trade-off and why you would even want this in the first place. If there are any things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.